Our next presenter this afternoon is Philip Garford. Philip is the Managing Director of Garford Farm Machinery Limited. He spent his early working life on the family farm. He has a keen interest in agricultural engineering, and a number of farm innovations ultimately led to the production, the formation of Garford Farm Machinery in 1986. Initially, it specialised in sugar beet harvesting equipment, but soon became involved in the production of mechanical weed control equipment and technology. And that has become the mainstay of the business and will be the topic on which Philip will address us this afternoon. Thank you very much.
And not forgetting to put the glasses on. Thank you very much to the Academy for inviting me to speak. I guess I'm here representing the other end of the industry, with a turnover of about 3 million. I don't know how many class combines that buys me, but not a great deal, I don't think. So Garford Farm Machinery, providing advanced technology for progressive farming. Sounds good, doesn't it? Our speciality, as many of you probably know, is looking for weeds in crops and finding ways of destroying them generally. That can quite often start with us looking for the actual crop itself and then deciding to try and destroy anything else that we don't think is crop. So, how do we do that? Our brand name Robocrop basically covers all of our product that uses cameras to view the crop, and then by analysing the images we're locating that crop and or weeds to then carry out the necessary control. Now, back in when we first started with the Robocrop products back in around the 2000 era, our main product at that point was the Robocrop precision guided high-speed hoe. So with that, we're using the cameras to, very much in the way that Trevor just pointed out with one of their products, locate the crop rows, and then using mechanical feedback control the track of said hoe. That's allowing us to then achieve fairly good accuracy and work rates. So I don't know whether we can point here, can we? Well, you see on the framework of the hoe there, the silver pole sticking up houses the camera that's looking down at the crop, which is represented by the graphic there. That's the live graphic that the operator will be referencing in the cab, and we're analysing the images as they come through to find the exact crop rows, and generally try and keep the grid of rows that we're looking for in the centre of the image, and by ensuring the camera is positioned correctly and or using our fine offset features, ensuring that the tracking of the crop is suitable to run between the crop rows instead of hacking up the crop and leaving the weeds, which would be most unfortunate. We're generally steering the implements via hydraulics, although we are doing some work at the moment using electrical control rather than hydraulics, through the demand of our mostly of our vegetable growing customers, who are a bit averse to taking a lot of hydraulic flow and pressure into their valuable vegetable crops. So we're basically looking at a colour image, and we're analysing the images at about 30 frames a second, and analysing the colours of the crop that we're looking at. We're working in any colour that we care to find in the crop, but it's generally a lot easier for us to locate the crop if there's a good colour differential between the crop itself and the background colour of the soil. But as long as that difference exists, so as long as we've not got generally brown plants, then we can usually lock on and do the necessary. We do that by firstly converting the colour image into basically a black and white image where we're seeing the colour amplitude across 8 bands of the image, and we're filtering that through a Kalman filter to match it to the grid lines that we previously programmed in for that particular crop to find a best match scenario. The graphics on the screen there with the blue crosses down the middle indicate where for each band we're actually finding the centre, effectively the centre of that part of the grid, and then we're finding a line that takes us through those crosses as accurately as possible. The result of that is that generally in most crops we're able to operate with an accuracy of something like plus or minus 10 millimetres, and speeds of sort of 12 kph are the normal sort of operating speeds, although we've had customers operate at faster speeds than that, and of course many of the vegetable industry customers will be operating at far slower speeds in order to keep soil throw to an absolute minimum. Hopefully, yep, here we go. So we saw in most of the images there some fairly obvious crop lines, but sort of play this nice little video because it illustrates quite nicely some of the things we can do where we've got good differential between the crop colour and the background colour. We really don't need much as far as the plant is concerned. Whether I can pause this, you probably won't believe that there are actually any plants there, but we have to catch the little critters. Yeah, I'm not doing too well here, but believe me, we are staying nice and central of the. I think you can see the outline of the shadowing of one just there. So as long as we can scale up or down the resolution that we're working to very simply by increasing the height or decreasing the height of the camera. So in a situation like this, we would use possibly just one camera, possibly multiple cameras to get quite close to the crop, identify those plants, and you can see them flickering through the centre there with the shadowing of the leaves if you look carefully anyway. So, you know, even on a very small crop, it is possible as long as we've got that differential between the colours and not too much advanced weed growth. Certainly all the early development that took place was relating to inter-row cultivations, but the industry's changing. We're finding more and more challenges as far as normal weed control methods using selective herbicides is concerned. One of the biggest problems that we're facing at the moment seems to be with resistant blackgrass in the cereal crops. And one way of effectively treating a high proportion of that problem is through inter-row spraying. So again, an important place where Robocrop guidance can play an important part, giving us very accurate guidance and allowing us to spray non-selective herbicide between the crop rows. The biggest problem there is we've actually got not a great deal of non-selective herbicide that we can choose from, but we're hoping that situation will improve over the coming months with getting approval for various new types of chemical to be used. So that was with the Intero guidance. The next challenge for us regarding our Robocrop system was to actually not just locate rows of crop, but location of individual plants. So we're using very, very similar imaging technology, but this time we're looking in 2 dimensions rather than just 1 dimension looking for the row. So once we've found the crop row, then we're looking along the row to get a good match for the grid that now features also crop plant spacing along the row, as well as all the other settings that we put in. That heralded the development of the Robocrop in-row weeder, which features the little rotor here that hacks between all the plants, again for the same purpose, to destroy the weeds. The very latest development in it's a bit black, that, I don't know, looks good on the screen here, I assure you. The very latest development, we've gone to, as I mentioned earlier, totally electrical control, totally electrical drive on everything, electric rotors and steering, etc. Particularly valued by the salad vegetable growers, where of course contamination of the crop is something that cannot be entertained at all. So here you see one of our 24 row lettuce in-row machines. And with that, also going electric has enabled us to increase the accuracy of the performance around the plants, and also to increase the speed. So we're now able to operate at up to 6 plants per second per row. So the output, for instance, of that featured machine there, we're working at up to 3 hectares per hour spot performance. It's capable of the sort of results that some of the bigger growers are certainly looking for. So again, looking down at the crop with 2 cameras there, so we can see the whole of the field of view that the machine's going to be working on, and then analysing those images to pinpoint the exact centres of the plants. So with most of our vegetable growing customers, with salad crops, brassicas, etc., we're perfectly capable now of growing those crops without any herbicide usage whatsoever. And we're not, as I said, restricted to green crops. We can work on red and pretty much anything in between. This is a typical view that the operator will get the comfort of knowing that the system's dropping a cross onto each plant as it passes through its field of view. Quite a challenge working on onions, where you've got very little foliage to look for. So that's working at 3 plants per second, which is half the capability of the machine. The main thing that will stop you working at the possible 6 plants per second is usually soil throw onto the crop, which doesn't seem to be any easy solution to that at the moment. what next? So utilising our image analysis system, one of the problems, again, that has cropped up recently with the carrot, onion and parsnip growers is that they are facing a future without some of the most important selective herbicides that they've been using to date, and control of such things as volunteer potatoes in those crops will become impossible. This situation should have occurred about 3 years ago, but the chemical was given a bit of an amnesty, but that will disappear very, very shortly, and this type of equipment could be the saviour of that situation. So where we've got a situation with a young crop where we have clumps of weed growing, but those, as you can see here, these clumps of weed maybe are covering 1% of the actual total growing area, but we know if they're allowed to develop, they're going to suppress the crop. So what you really need is to be able to go through there quickly and accurately and hit them with a dose of a non-selective weed killer, and that's exactly what the Garford Robocrop spot sprayer does. So in this case, we're identifying the crop rows or not. If there are no identifiable crop rows, say the crop's only just coming through the soil, we'll still work in there, but we won't actually define the crop row. We'll just drive through looking for any clumps, and then the spray bar is just like a huge sort of inkjet printer and just fires a shot as it passes the crop, as you'll see in a moment. So the areas that are ring-fenced by the red perimeter lines there are what we've identified as weed, something that shouldn't be there, and as that passes under the boom, that's going to get zapped by the spot sprayer nozzles. So the orange nozzles that you see on the spray bar here are a specially developed nozzle that is capable of keeping to a very narrow spray angle and hitting the plants within that, but at the same time it was necessary to develop a nozzle that wouldn't produce a lot of fine droplets and would be very easy for us to direct and with no splash off from the plants. And importantly, we can turn that on and off with an effective spray in 30 milliseconds. That's allowing us to travel at a speed of about 6 kilometres an hour. We're able to turn it on and off in a distance of about 6 centimetres. So you can see the results there of that. So some pretty dead or almost dead-looking weeds growing amongst a very healthy crop. So clearly, the amount of chemical that we've actually used to do that is also drastically reduced from any overall spray that you might use to 1 or 2% of the volume. So the environmental benefit as well, of course, is clear. So that's the spot sprayer at work. See a close-up in a moment, hopefully. So you can see there the nozzles spitting away at the plants as they go, and so as you can clearly see, the actual volume of spray that we're using is extremely low and just directed at the individual weeds as they come under the spray bar. So I don't know whether that's been 15 minutes, but I hope that's given you a flavour at least of what Garford Farm Machinery are about. Very specialist little niche that we've found, and yeah, that we feel we're being quite successful at. So thank you very much.
Philip, thank you very much for that. Do we have questions for Philip? One at the back, please.
Peter Goodhue of the University of Liverpool. Could you comment on what are the engineering technical features which limit what you can do at the moment? In other words, what advances in engineering do you want for your next decade?
Oh, that's a wish list, isn't it? Yeah, the limitations. The limitations have been, I guess, that we've been using. The image analysis has been focused on two-dimensional colour images, and that's not always that clear as to what we're doing as far as locating the plants or weeds. Our current research has gone into the third dimension, and it's not been quite as positive as we hoped it might be at the moment, but I think as an add-on to what we're doing, it's going to extend what we can do. The technology, as far as the spray technology that we saw at the end there, is we're working on. Although we found a nozzle that works pretty well for what we're doing, we are working on a couple of other nozzle designs as well. It's very much a niche market that we're in, and we tend to be working on the next. The next challenge as we go. So I think with the fact that we seem to be answering those challenges as they come along, we're quite happy with where we are. But it's difficult to say really what the key challenges may be, as we're just working on the ones that have come up so far.
Thank you very much. Simon
Blackmore. You mentioned already that with your smart sprayer you can reduce the amount of herbicide being used right the way down to 1-2%, saving 98%, which is pretty impressive. Do we need a change in legislation to allow us to continue using these active ingredients when they are being so accurately targeted?
Yeah, definitely. I mean, there's already been some progress in that respect, but certainly for some of the problems that we're facing and some of the applications that we saw there, the legislation at the moment is not actually allowing us to carry that out in a commercial environment. So, I mean, inter-row spraying of total weed kill chemicals, some of the chemicals that we know will do a very good job, it's actually illegal at this moment in time to use them, despite the fact it's clear that the environmental benefit will be quite enormous. There needs to be some legislation changes for sure.
Thank you. There's a question just here.
Simon Howison, retired engineering director for BAE Systems Aerospace. I'm used to seeing image recognition used to find targets to bomb. It's quite cute to see it being used to hoe around weeds. I rather like it. Yeah. But I'm sort of left with this impression that the big downside to it is this very large pair of tractor tyres trundling down the field doing immense damage. Do you have any sort of move forward as to how to avoid that? Yeah,
well smaller tractors is certainly possible. With most of our equipment, the necessary tool for powering it through the field could be a fraction of the size that we're often asked to deal with. And it's simply because of the average tractor size on farms these days, that's the size that they are. So even though they're designed to do big tillage operations, etc., it's the tractor that's available when it comes to spraying time. But for sure, I mean, we are working in some places. We've got people using lightweight tool carriers and things like that, which is obviously tremendously more efficient. This is very true. We do what we can.
Thank you very much. One more question here, please. Thank you.
Mohammed Issa, Kwara State University, Nigeria. Please, I'm not too sure whether I saw the mechanical hole making almost a 360 degrees turn. The mechanical weeder.
Yep. In fact, it's not doing a three. Well, the hoe blade does a 360, but it's a looping action in and out of the gaps between the plants. So we're actually going in and back out the same side of the plant. We're not actually going all the way around it.
Yeah, so I suspect that you may not pick all the weeds. What is the efficiency of the weeder then?
The efficiency of the weeding operation is, and let me remember this, obviously it depends very much on the uniformity of the plant as to how certain we are that we've found the centre of the plant and that we've found where the stem of the plant enters the soil is the important thing usually, because it's the roots and the stem of the plant that we might cut if we're inaccurate. So as long as we've got a nicely formed plant, we will normally leave a plant zone of about 6 centimetres diameter around the plant. And so if we're looking at plants that are spaced, let's say they're spaced about 250 millimetres apart. So we're probably something in the region of doing about 93%, something like that, of the total surface area. But the point is that normally when we're going in there at that stage when the weeds are starting to grow in such a crop, we're usually undercutting the foliage of the plant. So what we don't get with our blade is being suppressed by the foliage of the plant itself anyway. So that's sort of the efficiency we're working to normally.
Thank you very much. I'm going to call it to a close there, Philip, and thank you very much indeed
Thank you.
for the fascinating presentation. Thank you.